great to be here again. It's an honor to kind of be the first presentation here on the SMB track and being the first one to present on Samba stuff and Samba development and stuff that we did in the last year, and what this talk is about, what's going to happen in the near future. Most of you will probably know me, but in case anyone is here who doesn't know who I am, my name is Böhme. I work for SerNet, and I work on Samba since more than 10 years now, and will hopefully continue to do so for another 10 years. We'll see. So in this talk, I'm going to mostly give an outlook of what is going to be happening in the near future in Samba, what is coming, what exciting new features are on our roadmap. But I want to start this with a quick view back and share quickly what we have achieved in the last year in Samba versions 4.20 and 21. So 4.20 was released more or less exactly a year ago, and 4.21 was released 6 months later. And we had some nice stuff in 4.20, particularly support for the witness protocol, which has been sitting in a Git tree of my colleague Metze for a very long time, because before we were finally able to really finalize this and get this merged into 4.20. That was a really nice addition, and also we got I would say some initial experimental support for SMB Unix extensions, particularly exposed by adding a new option that we added to, that was defaulted to off, but you can enable it. And more on that later in this presentation related to SMB Unix extensions. But it started to kind of appear in Samba in 4.20, and there's been a lot of progress then in the background in later versions also, but more on that later. So that's mostly it in 4.20, and I'm kind of constraining this presentation on the file server in Samba. So as you may probably know, Samba is also a full-blown Active Directory domain controller. And there has been a lot of activity in last year in the Active Directory domain controller part. Most of you are probably not really interested in that part, so that's why I'm skipping that here. So this is really mostly about the file server. And so what was then added in 4.21 in spring of this year, in March, a few small features. We finally got back LDAP, TLS, SASL channel binding support, a few other small features. One nice thing is some recent activity in the Samba Ceph community, which resulted in developing a new VFS module for Ceph. So for having a clustered Samba file server in an enterprise with Ceph backend. There's been some activity there. It's ought to be basically a performance optimization achieved by using a lower level API of the libcephfs library that was used previously in the existing module. So there was a somewhat nice one. So I mean, that's a quite short list, I would say. And I don't know, any of you know any of protocol features that are currently missing in Samba? Out of the head? No, not really? You will see. There's a lot coming. And I want to start this with showing you this picture, which probably most of you already know. I think it became kind of famous 2 or 3 years ago when this big log4j, a Java logging framework disaster happened, where all over the world, Java enterprise applications, they were using the log4j framework for their logging, and there was a security hole in that small framework, in that library that everyone was using. So every Java enterprise application in the world, and many of them, had security issues there, and there was a huge outbreak there related to that. And this was a very small random project, and all of the other infrastructure stuff was sitting on top. If you can read it there in the back, this is saying all modern digital infrastructure, a project some random person in Nebraska has been thanklessly maintaining since 2003. And I think we were in a better position compared to Log4j. So I don't think we are that very small brick down there. I think maybe we are one of the bigger bricks on the left side. But still, I think coming back to the list of stuff that we had in the last two versions, it kind of shows there's some stuff missing. So the good news is, and this is kind of went public last week, a German federal agency is investing into Samba development by working with us, SerNet, to develop many important features in Samba. Now, the Sovereign Tech Fund is a German federal government funding program. Goal is to sustainably strengthen the open source ecosystem, and I think they've been around since like 2021, so a few years. They have a decent budget of something between, it changes over the years, 22 million, 60 million, so it's a start for decently funding some projects. And some other funding projects that were funded include stuff like GNOME, FreeBSD, and Log4j was also one of them, PyPy, and many others. So they're doing a really good job of investing there into the open source ecosystem, right? And we learned about this like a few months ago, that Samba would also be something that they would be considered something they would be able to fund. And so we applied to, as SerNet, as a company, to have us work on Samba features. And we got a really decent budget here, like 680K euros. This is, I mean, it's a contract between companies, but this is publicly shared on the webpage of the tech fund, so I can freely share this also here to kind of show that this is really something which will have a big impact on Samba. And so in SerNet, we will be working with the three developers, Samba developers that we are in SerNet, so my colleague Volker and my colleague Stefan and myself. We will be working on 8 important protocols, Samba features, and also a few other things over the next 18 months. This already started like 1st of September, so since 2 weeks we are down in the basement, busy hacking. It will go for 18 months, and the estimated project development time is like 2.25 years spread across 3 developers over 18 months. And it's 8 large features. So here's the list with the stuff that we will be working on. And this basically covers a list that includes features that have been included in the protocol since 12, 13 years, like persistent handles and that. And now finally, we will be able to tackle them. Unix extensions, directory releases, persistent handles, SMB over quick, SMB direct, some performance stuff, which is not really protocol level stuff, but aiming at improving performance for I/O and metadata performance. And also some security-ish features, net logon security hardening, and SID filtering. And to me, that was like Christmas. That was really like Christmas. That was so great to get this to get this approved, to get this contract, to be able to spend the 18 months working on these great features. For many of them, we have prototypes sitting in some Git trees somewhere on either Volker's or Stefan or my laptop, but it still requires so much effort to like add tests, to finalize everything, that we never got there to really finish all these prototypes that they were even working to some extent. So we will now be finally able to work on this, and all this will be done in the open and will then pushed upstream into Samba. Into every 6 months there will be, as usual, a new Samba version. So that's the release cadence that we have in Samba. Every 6 months we release a new major version, and as we go through this and work it and finish it, the new features will appear in Samba releases. So going through these features and giving a few some insight into the challenges that we will be dealing with in the next months. So for the SMB3 Unix extensions in Samba, that has been there's been some much work been done on that by particularly Volker, and in Samba in the server. Many things do already work, but there's still some subtle stuff where we haven't, in my opinion at least, not actually even achieved agreement on how to handle certain stuff at the protocol level for Unix extensions, and all these things will now have to, we will sort that out and get this done. We have these SMB3 Unix extension specification PDFs or HTML versions, and we initially had there was initially drafted 3 or 4 or 5 years ago, but it only contained the on-the-wire protocol extensions. It didn't include the server behavior or the semantics of the file system that you're supposed to expose with the server. That's going to be subtle and tricky work, and luckily we will be able to dedicate a lot of time to get all this done and hopefully get this ready for one of the next major versions then. Next important features is SMB3 directory releases. That was introduced in 2011. I just checked last week. So it's 13 years ago that was added by Microsoft to the protocol, and we haven't had this for all the time. It's a nice caching, so it allows caching of directory metadata on the client. So depending on the specific workload that the client is running against the server, this achieves some considerable saving of packets sent to the server. So I wrote a prototype already for this in 2021, like I said, so we have prototypes for many of these things sitting in some Git tree. And most things do work. I'm currently basically busy writing tests, adding additional tests for this for our automated CI test suite. And unfortunately, I kind of forgot this initially, but then last week I realized that we have an existing bug related to our handling not of directory leases, but of plain file leases. So currently, we don't break handle leases when deleting a file. Apparently we got away with that in the file server in Samba without too many complaints. I think a colleague from give me a second, a colleague from Günther filed a bug report something like 3 years ago. As far as I remember, but besides that, we didn't have any customer complaints or on the mailing list. I never noticed any. I mean, this might cause some havoc and some sort of weird behavior on clients, possibly, or random data corruption, which nobody ever figured out. But yeah, so for directory releases, this becomes even more important. So that's one of the things that I'm going to have to fix as part of the directory release implementation. Brett. Okay, so let me repeat the question. I'm so proud I remember to repeat the question. Yeah, great. So the question was, if we support the unofficial way of upgrading leases, and my answer would be, as far as I know, that's actually not unofficial. That's part of the protocol. I think it is, but don't name me on it. So that's at least my working assumption, and that's what we also do. And that's already what we do in Samba anyway, that you can upgrade leases. But I'm pretty sure that we could ask Tom later on, but I think that's part of the protocol. But yeah, that's from memory. But we support it anyway already. And so for directory releases, I think this is not that important, because for directory releases, you mostly get broken anyway from read handle to none for metadata changes on the server. And then, I mean, okay, you could upgrade then again and reestablish your lease. Yeah. Okay. So next one, it's one of the biggest features which will require a lot of work, is adding persistent handle support, which was also introduced 13 years ago in 2011. And the basic complex problem is that this requires very subtle and complex changes to the way that we store our file handle state on the server. I have a prototype for this since, like a few years. I gave a presentation on this 6 years ago. And it's like the SMB layer changes are trivial, but for Samba, the challenge is to store the persistent handle state without impacting like other stuff like performance or semantics on a cluster is tricky. And as you can see, so my prototype code quickly ran a git diff. It changes a lot of files. The diff itself, it's not that big. It's like only 6,000 insertions and 400 deletions, but that will grow. And it's something like 150 patches. So let me check into how much detail I should go. So it's only 20 minutes in. Yeah. So I could bore you with all the details of what the plan is to implement this. There's a question, Volker. You said you want to be bored by the details. I mean, to be honest, I would say then check my presentations from 6 years ago. But I tried to put this into 4 bullets. The basic idea for storing the handle state in the backend is currently in clustered Samba, we have 2 kinds of databases. And from database theory, the main difference between those 2 types is basically one is just non-replicating. So data is stored just on a single node, which in a cluster for data safety is something which you might think, hey, that's not really safe, because if that node goes away, then the data is gone. But this has worked very well for us, because without persistent handles, typically, these database records that we stored there were used for storing file handle state. So typically, without persistent handles, what happens if an SMB client is connecting to a server and that server just dies, then that client will reconnect anyway and reopen all its handles, completely new. So it doesn't really matter if we lose the file handle state, right? But with persistent handles, that has to be changed. We have to persistently store the handle state on persistent storage in order to be able to protect the handle and access to the file from concurrent access from other clients. And so the idea is to kind of change this model that we currently have, where we only store the file handle state on these non-replicating databases, which we in Samba terminology we call volatile databases, to also store this state based on a per record store API flag, also on a persistent database. I mean, that kind of sounds trivial, probably, and obvious. And actually, it is pretty straightforward to implement this, but the devil's in the details. Yeah. Is that understandable? Don't see any nods, but yeah. We will get that. Yeah, okay, let's continue. So SMB over Quick. My colleague Stefan has been doing some prototyping there and looking into this, and he will be working on this. And the good thing is that just last week, I think, there I saw, well, it's not a merge request. It's the traditional way how you get patches into Linux kernel upstream. So you send an email with lots of patches. So merge request to add IP proto quick support to the Linux kernel. To have, yeah, Steve is nodding. Yeah, which is really, really great that we have some progress there. So we were previously already aware of that effort to add quick support at the socket API layer to Linux. There was the project was hosted on GitHub, and we became aware of that like last year or something like that. And now it looks it's on its way into the Linux kernel. And with that in the kernel, it's basically straightforward for us as a user space program to implement SMB over Quick if the socket API proper just offers quick support at the socket API level. Right? Steve, question? So I think, as far as I remember, the response from the Quick, the developer that developed the code to this suggestion. So what about the performance is slower, and what about IOU ring using IOU? So I got to repeat the question first. So exactly, thanks. So the question was, what about the relationship between IOU ring, Quick in the kernel and performance, and possibly using IOU ring to enhance performance then of the Quick protocol, right? And so to be honest, I don't know. That has to be seen. And I mean, honestly, for any really of those very detailed IOU ring related question, my answer would be go to Stefan. Right? Yeah. But to me, it seems this is something that has not really been worked out and fleshed out at the IP proto Quick level first. And whatever they end up doing, if it's usable with IOU ring in the end, then yeah, we can make use of that, sure. So that's probably the easy part, and I think we have prototypes for that. What is probably going to take some substantial effort is to add support for the Quick protocol to our so-called socket wrapper library, which is something that we use in our automated testing environments in order to be able to basically run and spin up and start Samba domain controller, Samba file servers, and connect them together, run tests against each other, multiple forest setups. If we do Active Directory tests or SMB client tests, then we start up a server and we start up a client. And all this can be done as a normal user thanks to using socket wrapper, which basically intercepts all TCP communication and wraps that into communication over a Unix domain socket. There are also more wrappers which basically catch user ID, set user ID calls, and stuff like that, which in the end enables us to run complete file server or socket daemons as a normal user, and multiple of them, and have them connected to each other and talk to each other. And it would be ideal if we would be able to add support to Quick, also to socket wrapper, to then be able to have extensive tests for this protocol in our automated test suite. And yeah, I mean, that's basically it. There's also like a user space quick library. So if on older kernels where, I mean, this is just in the process of getting merged to Linux, the IP Proto Quick Socket API. What do we do on older kernels? What do we do with clients running older servers that want to connect to like the cloud? If you use, for example, GNOME application on a Linux server that uses our libsmb Samba library as an SMB client to connect to servers. How would that work if you possibly would want to connect via Quick to an Azure SMB server, something like that? And there's a user space Quick library we could also use to add support for Quick to our client tooling. It's not planned to use that for implementing Quick support in the kernel. For that, we will rely on the socket API changes, but possibly we will use that for implementing client-side support, which probably the most prominent user of that might be something like GNOME VFS if you connect from a Linux system with GNOME to an SMB server. Next, SMB Direct. That's another very big one. My colleague Stefan has also been working on that. Is he actually here? No, he's not. And this one requires some extensive kernel module work in order to expose the SMB direct support from the kernel to the user space, to a user space application like Samba, which is currently not possible. And if I get this right, so currently there are 2 SMB direct subsystems in the kernel. One is used by the sys client, and the other one is used by KSMBD by the server. And the plan is first to look into merging those 2, and also ideally not adding a third one that is then exposed to user space, but only having one consolidated subsystem there that can be consumed then from user space as well. Steve? Okay, so let me try to repeat this. So Stephen commented that this merging and consolidating is not only good for Samba then and exposing to the user space, but also for enabling more use of that by other components in the kernel. Yeah, okay. Any other question? No, okay. Yeah, and then a lot of work to integrate it into SMBD actually. The integration then, when we have it in the kernel, consolidated the kernel modules, expose the stuff to user space. That's the hard stuff, and then consuming then that from user space like SMBD in Samba. That's more or less straightforward. We have patches for that. And what is going to be a tough nut to crack is how to add automated testing for this to our CI. This will be something that ideally, as I mentioned previously, this socket wrapper stuff that we have, ideally that would be able to also to understand SMB direct if it intercepts the sockets, the communication between the kernel and user space, and then emulate that and then pass it over Unix domain socket that another user space program, then a Samba client can then fully communicate and bypass the kernel communication. That will be ideal, and that will be probably one of the tough nuts to crack here. So next is performance. Who's not excited about performance with IUring in this case? Basically increasing usage of IUring in Samba. We already have like a IUring VFS module in Samba that you have to specifically configure. And then it's only used for a very small subset of stuff that you could do with IO-ring, which is basically doing the disk I/O, reading and writing to disk. That's all that we use it for currently. And there's a lot more which it could be used for. And the benefit would be that with the current state of the art, if we do some I/O-heavy workloads against Samba, what we see that in the end, we are CPU bound because we just end up doing a lot of memory copy in the kernel, where the data from disk is copied to user space, then it's copied back from user space to kernel, then sending it out to the network, and so and back and forth. And all this ends up at some point saturating CPU such that network throughput doesn't increase anymore. And so to get there, we do it in incremental steps. One is actually to replace the current default backend that we have for async I/O in Samba, and that is based on using a thread pool that does all the disk I/O in a thread pool. And the first step would be to kind of better integrate IO-ring on Linux or where it's available into our default event subsystem and stack. Make sure that we're not doing everything async, because if I/O is small, there's this nice preread v2, no wait, although syscall with a no wait flag, which kind of says if data is not already in the cache, don't go to disk. And that helps with small I/O latency. We have to integrate that as part of that. So on the steps for getting rid of all the mem copy is using the IO-ring operations for send message and receive message. So basically, not only doing the disk I/O, p-read, p-write via IO-ring, but also doing the socket I/O, receiving and sending data from the network via IO-ring. And that basically means that the SMBD process that has, so for a client that reads from the server, that the server process is not blocking when sending data out to the network. And it defers that to a kernel thread, so the pushing out of data to the network is done by the kernel. The Samba server process is not blocked and can then schedule more I/O in parallel. It's still going to do mem copy, but it will do it in parallel in the kernel and not single-threaded in user space. Okay, so that gets us some way. There's an additional IO-ring operation, send message 0 copy, but that's only, what was the story? That's only supported with certain, I think it requires support from the network hardware. I'm not totally sure here. But that is something that can be used to pin buffers and in the kernel and avoid an additional copy for the send message call. And then to continue to really get rid of all the mem copies, there's this the IO-ring operation splice. With that, it's possible to completely avoid mem copy for the disk and network I/O path. But there's a problem. And I think that's erased it on the Linux kernel list like last year. So the way it works with splice is that you read data from disk and you put it into a pipe buffer. And that means it's not copied because it's taken from one place in the kernel and then just referenced in pipe buffer references. So it's not copied. And then when you want to send out that data to the network, you splice again from the pipe buffer to the socket. Again, without copying. The problem is, while the data is sitting in the pipe buffer, it can be modified by write operations on the file. And according to the discussion on the Linux kernel mailing list last year, that's the behavior that the Linux kernel wants. But that's different from what you get if you just use preread to read to user buffer, right? That data is stable. So you can read into a from a file into the buffer, have that buffer sitting there for a year or two, and then send it out. And no one will change it until you screw it up, right? So these are subtly different semantics with the risk of data corruption from the client perspective. It's really unfortunate, and we have ideas how to work around that by possibly only exposing this or only using this in case the client has actually like an exclusive lock, or a caching lock, an op lock, or a write lease on the file. Right? But that kind of restricts this to only a subset of possible workloads that we might see. So yeah, a lot to figure out on that end. But we will see quite some nice performance improvements there in Samba for mostly for I/O, reading and writing files, small I/O, large I/O. But the plan is then also in the future to make more use of IUUing also for metadata operations. So basically, listing a directory, doing all that via IUUing, opening the directory, getting the dir entries, and then doing a stat on all the dir entries and all that in parallel via IUUing in the kernel. That is not going to be part of that. That will come then in the next stage. But this lays the foundation for more work in that regard. So continuing, there are no questions. So some security stuff that we will be working on, and one of that is netlock-on security hardening, which is stuff that Microsoft has also recently updated in the protocols, and it's basically some security hardening of downgrade detection, downgrade protection when using netlock-on, and also getting rid of NTLM for cryptography and using Kerberos for netlock-on. So these are some important security work and feature that we will implement here in order to also keep up with Microsoft is doing there. And also something that is a subtle important security features. It's more on the Samba Active Directory side. 10 minutes. Yeah, I'm fine. Last slide. Thanks. And that is SID filtering, which is a security feature basically in order to establish a tighter boundary in Active Directory trusts when you have forest trusts and you have user tokens pass security boundaries. Currently in Samba Active Directory, their SID filtering is not implemented, so Active Directory forest trust in Samba do fully trust each other, and also can be it can be exposed that a domain controller in a foreign domain can inject SIDs into the token that you will be using that can be used for security privilege escalation. So this is also something important. Yeah. And that's it. I think that's a lot for 18 months. So now, questions. Steve.
So I was curious, IOU ring numbers look really good. I think was it a year or two ago you presented how much performance gain you got from it? Do you remember how much?
From 5 gigabytes, so single client.
Single client, yeah.
Or was it maybe like using Repeat the question. What were the numbers that someone presented like 2 years ago, improvement with using IOU ring? Question from Steve, and the answer is, so the numbers were mostly single client benchmarks, doing large I/O, and as far as I remember, going from something like 5 gigabyte per second to 30 or even more.
That's enormous, right?
Yeah.
Incredible. With SNBD just idle.
Yeah, so Volker commented with SNBD just idle, and I think the network was saturated at that point, as far as I remember. Yeah. And SNBD CPU was 10, 20, 30%, so there's we weren't CPU bound anymore, so but network bound. Anything else? Oh, okay. Thanks a lot for having me. Great, thanks.